So today I'm gonna walk through the new paper recently published by DeepMind and University of Tokyo. It's called Real-World WebAgent, and here is the amazing achievement this paper published. So the whole title is a real-world web agent with planning, long context understandings, and program synthesis. So it achieved higher success on website understanding and 18.7% higher success on automation and state-of-art performance on Mind 2 Web on par with GPT-4. So we will cover through the whole picture on these slides. And who am I? I am coming from the product backgrounds with all these AI, especially on the NLP techniques. So let's get that out of the way. So a brief history of HTML and JavaScript. So HTML was proposed by Tim Berners-Lee. He was a physicist from UK, and he proposed it in 1989. Um, and the HTML was built for researchers to share and update information. So it's important to keep in mind that it was not built for the regular people to interact. But then Netscape came along and they introduced JavaScript in 1995. It took only 10 days to make it, and it was to build the HTML. So those two are the main actors for these papers. HTML usages and the website usages have exploded in the past 30 years. So these are some of the key timelines that have happened with the HTML and the whole ecosystem of websites. Needless to say, there are so much data around this ecosystem that we need to utilize on. So this is some of the recent timeline development for the web agent. So OpenAI released a simulation environment for a website called Mini Wob, and that is for researchers, AI researchers, to build autonomous agent to interact with the real world website. And then since last year, things started to pick up. So Mini Wob plus plus is the standard web agent testing that people use today, and these are some of the names that will appear in this paper. Min2 Web and Flan-U-PaLM. So the paper was published in July this year. It was still preprint, so just to keep that in mind. But things move so fast in the AI field, it's good to keep track with the preprint alone. So these are the main concepts that appear in this paper. Mind to web, that's the data sets and the testing framework, and HTML5, that's the model they generated using self-experience supervision technique, and Flan-U-PaLM is the code generation tool. So this is the overview of how the web agent is functioning. So they get the task from the user, something like go search this apartment, and that task would be subdivided into subtasks. So go search and this apartment with the filter below $3,000, for example. And then it will find the similar relevant HTML snippets, and it would make a code and generate the code and execute it. We will go through the detail. So these are the unique challenges this web agent is trying to solve that is impossible with the current landscape of LLM such as GPT-4. So the current approach is one prompt, one decision making. So it's not dividing the subtasks, dividing into subtasks. So every time you make a prompt, the agent or this LLM has to work as one role, and they need to switch around, so they cannot follow the sequences of decision making. And the second difficulty today is the landscape of LLM is focused on the text, so it doesn't have any syntax information from HTML. And HTML is very rich in hierarchical information, and it's impractical because the context window is not feasible with HTML with so many tags. So this is an example I input with one of the Amazon pages into OpenAI system, and GPT's 3.5 turbo 16K window. Well, that means it takes 16,000 tokens, but the real world HTML from Amazon takes up about 678,000 tokens. So it's definitely not matching the requirement. And another challenge was that simulation versus reality. So mini wob proposed by OpenAI back in 2016 or 2017, sorry, was this size of token, but this is what the real world website represent in terms of token size, and this is about only like 5% of other real websites. So the solutions being proposed by this paper is these are some of the concepts. So it's doing the modular design. So it's combining two large language model, HTML5 and Flan-U-PaLM, to achieve the end result. And this is end-to-end solution. So it's doing the understanding of the task and filtering the areas of HTML where it matters, and it generates the code to execute. And it accommodates the open space field, so it's not just simulation, but it handles more of real world websites situation. So this is the flow of this web agent. So it gets the input, like go to this website, and this is the instruction. So can you find me one bedroom apartment in San Diego that has a fitness center? And it gets this HTML, the whole HTML as input, and then it will output some instruction and type in San Diego into search, and it also outputs the snippets. So these are used as HTML tags for this another model to generate this Python code to interact with the HTML. So it's divided into history of previous predictions. This is the language instruction as well as HTML page, and then there's the planning and snippets, and this is the Python program that gets executed with Selenium. Selenium, for those of you who don't know, it's a web automation driver library, so you can simulate a lot of front-end code on this library. People use it for end-to-end testing often for front-end dev. So these are the two model web agents this paper is proposing. So HTML5, it's the domain expert language model, and it predicts the sub-instruction for the next step, and it summarizes the long HTML. Flan-U-PaLM is another one that generates Python code and runs on Selenium. So HTML5 is a pre-trained LLM. So it takes in global attention, it captures hierarchical syntax of HTML. It's handling the long span denoising, so it accommodates HTML specific syntax. HTML contains a lot of gibberish as well, such as these open bracket or closing brackets that has not that much meaning, so it needs to accommodate longer span of denoising. And they're using this technique called self-experience supervision, so it's accommodating the real-world feedback mechanism. We'll go over this too more in detail. So this is the denoising and local global attention. So HTML denoising is usually they use a span length of 3. So 3 characters basically has so few information like ID equals, but you don't have the value inside. So they're using the span length of 8. So it accommodates this element name called form or type submit. That's the whole length of denoising. And this is the graph of local versus global attention. So this is the local aspect of label, and then going up the parent element to be fed into the global attention. So this is the HTML5 training flow. So they use these data sets from a common crawl. They're using 100 files, and they first clean it by removing the script and meta tags, and they're keeping the ID type values. For this one, they extracted the subtrees around label elements that have 4 attributes. So that's the HTML specific configuration. So that's often used in relation with form element. So they extracted about 3.41 million examples, and these are configuration details for the training. So they pre-train that model first with TPU, and they use fine-tune it. So in this fine-tuning process, they use the self-experience supervision. That's the technique they used. We're gonna go through that. That's interesting. So the output was 3 models for this HTML5 with different parameters. So the largest one they produced was 3 billion parameters, which is not that big, considering GPT-4 is something like 1.5 trillion, I believe. So that's good. So fine-tuning HTML5, so they prepare the instruction first, so they measure the success rate of 20 different natural language instructions. Natural language being like, go search this. And they parse that instruction. So apartments 4 will be one section, and then corporate housing with will be another, and then studio bedroom and will be another, etc., etc. So, and find relevant HTML. So they use regex-based retrieval specifies the HTML element to be summarized for the further task, and based on that regex-based HTML elements, they generate this PaLM Python code to manipulate HTML, and that gets executed to mimic the browser behavior on this Selenium library. So this is the self-experience supervision. Please ignore this. This is a mistake. But yeah, they get this real-world program feedback, program execution error or dead-end URL when they follow the path, and retrieval errors such as like document.get. So if you know JavaScript, that's how you interact with elements. So document.get elements by class name. And you insert the class name and it finds the element, but if that class names don't exist, it will throw a retrieval errors. I think this is very brilliant system to get this real world feedback. So they are trying to leverage this real world environmental feedback instead of relying on simulations. It can handle much more complex situations, and it's more generalizable outside this simulation. And they call it closed loop feedback. So compared to open loop feedback, they achieved about 50% success rate higher than this one. So they made this automation process possible with this self-experience supervision technique. This is another model called Flan-U-PaLM. So it's a code generator that's being published last year. It's not their main contribution, but they used it in a very intelligent way in combination with other techniques. So they get the program generation, and they also they get the next sub instruction, and they taking the HTML generated by HTML5 and they output a Python program. So the model size is about 540 billion parameters, which is still big, considerably big. So they don't get to fine tune it that well. They use a few shot mechanism. So this is an example of Python codes that gets generated. So they use this comment section, like typing Walnut Creek into search. So they treat this comment as a sub instruction, and these codes are getting generated. So this is a comparison for HTML5 with other popular models such as GPT. So they're using local global attention while GPT is multi-headed. So this is much more clear boundary, whereas in like multi-headed is the attention model is like going everywhere. And the data sets they're using are raw HTML, and GPT is taking in the script text documents from website as well as books. So GPT only cares about text, while HTML5 takes in the syntax information as well. And HTML5 outputs the sub instructions as well as HTML snippets for further task for the other model to generate codes. GPT just outputs the next word and next word to next word. Masking also, the HTML5 is taking the 8 characters to mask, and GPT is masking the next token, i.e. word, basically word. So Mind2Web is not their contribution either, but this is an important concept in this web agent field. So this is the data set for evaluating generalist agent for the web. It was released back in June. So what they did was they tracked user web activities such as clicks to achieve predefined tasks. Basically, they asked Mechanical Turks to get tasks to execute. In this case, it's United Airline. So this is an example of task: find one-way flight from New York to Toronto, and they got also they asked the participants to execute these in actions while recording. So go to the search box and then search for the flight, go to New York to Toronto, and then they inserted the calendars. So they tracked it. So it has about 2,000 open-ended tasks. It's hidden here, but across 137 websites. So this is the list of websites that they cover. So as you can see, they tracked a lot of wide range of industries or type of websites, so travel, information, service, and shopping, as well as entertainment. So this is the task planning part. This is some examples. So please search 2-bedroom and 2+ bathroom houses in New York with a max price of $7,500 on real estate website. So that's the high level instruction, and that gets broken down into sub instructions. Go to real estate website, type in New York, NY into search, etc., etc., and then that gets output into the next sub instruction, which is like typing 7,500 into max rent. This cannot be achieved until the model executes this click on max rent UI. So this has to be the next sub instruction. So there's a hierarchy of command here. This is a fun example which I'm not going to go through, but as you can see from Amazon, there are a lot of like hierarchical information. So if you go to Amazon website, you have this favorite festival that you can go through, and this favorite is also broken down into detour or ugly sweaters. as well as like holiday pajamas. And then within that category, there are a lot of list of pajamas to check out from. And then you got to check out the pricing section as well. So these are all sequential events that you need to look into. That's where HTML syntax comes useful when training LLM. So these are some of the potential concerns. So API is usually more privacy restricted and maintained by the developers. But in this case, it's easier to mimic human behavior on social media. Front end dev, which I come from that background as well, they are not that ready with how websites will be interactive with machines. Scraping traditionally was much harder and only reserved for like a big domain websites because you need to custom make each code per, they need to adjust the class name or ID. And some of the tricks they used to have, they still do, is they insert that unique key at the end of class name so that it's not easily targeted or executed by codes. But that will be very difficult if this approach manifests. And job displacement, because JavaScript developers might get a lot more replaceable. The jobs they do might be easily done with this AI. Trust. So if social media or website users become a lot more machines, the line between human interaction and machine interaction will be blurred, so you don't know who you're talking to more and more. LLM like GPT has done it already with the text, but with this agent that can command actions such as like or comment, it will make it much more difficult. So this is this is a real world example. So if you remember it from a couple of months ago, Twitter started limiting the number of tweets users can read amid extended outage. But basically, they started charging by API access, and they wanted to limit the bots from scraping their data. And because they don't know how to figure out who is bot or not, they just limited tweet reading for every account possible. So that's one example, but I can see that happening more and more with every website who doesn't want these machines to interact. So this is some final thoughts. So WebAgent is coming. The momentum is definitely picking up in this field. It produces a lot of possibilities, and people are unaware of what's coming. So this is what takeaway for me is this case showcased the interesting dynamics between encoded knowledge versus the action-based knowledge. So encoded knowledge being something that's being written down, such as science papers or Wikipedia, and those are synthesized by GPT and the current large language model. But they don't encompass any of the action-based knowledge. So what to do from here? So those are more robotics knowledge. So if you have you have to tell go search websites, you have to do it step by step, and that complexity of information is not well captured or synthesized yet. So I think this paper demonstrates that aspect quite well. And it's another research question that's interesting is what else can we think of utilizing the real world feedback for this mechanism. So instead of self-supervision, self-experience supervision using websites, what else can we use to train our AI using the real world feedback? Like self-driving cars need to rely on simulation because the the events of failure, such as crash or accidents, are catastrophic. They cannot do that in the real world, but there must be some other use case where we can utilize a real world scenario. Okay, so that's all for